Hey everyone, my name is Bret Simon. I'm the utilities partnership lead here at Exodigo. So Exodigo does underground mapping, which I'll get into a little bit more about how we really see ourselves in kind of this energy transition that the entire world is going about. But first off, a little bit about myself. I live in Seattle, Washington, on the U.S. West Coast. I've been in the utility industry for about 12 years. I used to be working with one of the big consulting firms. Don't judge me too hard. With PricewaterhouseCoopers for about, like I said, 12 years, working with asset management, work management, ADMS, outage management systems, really helping utilities and asset owners manage how the work processes, intake process is managed, as well as how it's prioritized, scheduled, executed, and then ultimately posted to the as-built, which is really a core utilities operation. But just like everything within the utility, it's being disrupted like no other point in our 100 years since the light bulb was invented by Edison. And so it's really an exciting time to be involved in the startup ecosphere as well as the utility ecosphere. So really, what I wanted to talk about today is kind of the topic of what should we do. I was actually at a conference last week with the Electric Power Research Institute, EPRI. So many of you may be familiar with that. It's a U.S.-based organization, but they have global reach. They had an electrification conference, and I mean, for the first time ever, and I'll get into it, disparate parties that used to be competing are really coming to the table, or parties that really didn't think they needed to interact. And for example, a fleet and auto manufacturers, public transportation, bus operators, and even just individual consumers are taking a more involved approach on how they manage their energy and how they obtain it. And so, with that comes some challenges from a typical vertically integrated utility on how do you adapt. And so, what I wanted this presentation to be a little bit about, and apologies for the preamble, was really what are some of the challenges facing utilities and some of the owners around the changing landscape of electrification, and from a capital development process, how you build up your rate case, how you justify cost and spend, how do you do that in a volatile environment? Again, apologies I couldn't be there in person. I really would love this to be more of a roundtable approach. So if you all enjoy this, happy to possibly do this in the future in person. And of course, give me a reason to come out to the UK because I do love visiting as well. So really kind of talking a little bit about the current state of the grid, looking at the promise of AI, and I will selfishly talk a little bit about Exodigo's AI and where we think we can help the capital project lifecycle. But again, we're not the only technology out there. The startup landscape is ripe with opportunity, but also it can be complex to look at what your options are. And kind of just finishing off with what utilities can do. And I will admit that's a little bit of an open question. And if we were in person, I bet you would all have a lot of ideas as well. I know SJP has said they can forward any questions you might have or any follow-up discussions. So I'm happy to kind of talk about that as we move into the discussion and post event. So as you all know, I tried to look at some UK articles. There's brownouts, blackouts. One of our customers, actually an investor, National Grid, especially when you look at storm response. One circuit fails, leads to cascading failure. And so just when looking at aging infrastructure, in addition to the additional capacity that's needed, there's a lot of risk out there. And kind of the easiest answer is, well, let's just fix what's old and we'll be fine. But then you have the answer or the question of, well, how do we deliver more capacity and not traditional capacity curves? And that answer of just replacing aging infrastructure doesn't necessarily work. And so there is a problem with not really a clear answer. So from a yesterday, the reason the yesterday's model doesn't work is it was really single directional. You have generation, transmission, distribution, and homes. So integrated utility model. You had a suite of power plants. I mean, you could fill in with some renewables if you wanted. And then it just was a cascading process to get power out to your customers. Today, you not only have more and more electrical or electrification options, it's distributed. And so customers are deciding to create their own power and then they want to sell it back, or they don't want to be connected at all. But that is only when power is being created by them. But the minute power goes off, then they want your power. And so there's this expectation of continued reliability, but uncertain capacity. And so I'm probably talking to the choir here, but when you're looking at long-term capital planning, there's a lot of change and a lot of volatility that can sometimes have this analysis paralysis mindset. And so, again, it makes me very passionate to be in the industry. And I hope most of you are extremely passionate as well and excited about the opportunity that's coming, especially across the world as we electrify and become try to attain our goals of a more carbon neutral society in the future, with electric being really at the forefront of that, as long as we can maintain renewable generation and clean energy sources. But there are so many moving factors and new stakeholders. I know sometimes EVs are the easy one to focus on of, hey, well, everyone's going to get an electric car. How does that change the capacity? But there are a lot of other variables, especially in the UK, where cold weather is an issue and moving more towards heat pumps. I know in the US, heat pumps are not as prevalent. The UK already has a pretty good penetration of that. But as heat pumps become more efficient, as water and other types of devices become pure electric, that does have an impact on when's the peak load and when's the capacity need to be managed. So yeah, again, talking to the choir a little bit, but it's an exciting time to be both the utility and a customer. So when you talk about what are some of the things that a utility can do, I kind of break it down into three kind of categories. The smart devices or smart things. I mean, it kind of started off in 2008, at least in the US, around AMI deployments, which I don't know, some could say was partially failure because they put all these devices in, but then didn't know what to do with the data. But now 20 years, or well, 12 years later, 13 years later, utilities are starting to figure out what to use that data for and using artificial intelligence to start parsing through that real-time data that actually you can figure out what devices are being used by customers and starting to tailor capacity, automatic load switching, containment of outages, self-repairing circuits, all that type of stuff. But when you look at it, and also even efficiency gains for transmission lines, you can have heat monitoring, wildfire sensors, things like that. Really IoT devices, kind of the sky's the limit on that type of asset. But again, there's a deployment cost, there's a maintenance cost, and then utilities aren't technology companies, and so trying to figure out the right mix can always be a challenge. When you look at advanced materials, I don't know how many different types of conductor companies, especially when you look at high capacity transmission conductors. There's a ton of science being thrown into this. I know I was just at a Department of Energy conference with the Advanced Research, or the RPE group, to look at, okay, how can we use what we have, but string up assets that have more and more conduit or conducting capability that can maybe preclude us from having to build new towers. But when you look at that, there's a number of challenges, failure rates. If you install new types of materials and something goes wrong, do you have to redo your entire grid of thousands and thousands of kilometers? And what's the reliability? And what's the maintenance ask or risk? So there's a lot of uncertainty. And as you all know, utilities are risk-averse models because of the reliability and need to provide reliable power. And actually, something to think about. We were talking in some of our workshops last week in this conference. I mean, there's always this need for 100% or close to 100% reliable power. But as we start thinking about the future and decentralized power, do customers need to start thinking about self-generating power, and is reliable power from your power provider not as certain as it needs to be? Or sorry, basically, if you're generating your own power, can your power provider become a supplement? And reliability, if you can have an affordable cost, are there trade-offs that need to happen? And actually, a great example of this is Puerto Rico. in the U.S., where the massive storm Maria came through and completely disrupted the traditional power provider, and now they're a great embracer of microgrids. And they live around the reliability of the sun and battery storage capacity within microgrids, and consumers are changing their behavior because of the known reliability of when power is available in greater quantities. Is changing consumer behavior. So that's kind of where the very interesting conversation around how can consumers change their behavior, even if you're not changing certain grid upgrades that we may need to think we need to do. But that's a little bit off tangent from advanced materials. But again, it's part of the discussion that if I was there in person, would love to kind of get your guys' input, and so happy to have the discussion offline. And then finally, I mean, when you think about kind of smart devices, advanced materials, you look at just traditional construction replacement. I mean, at least here in the U.S., and I know in the U.K., a very, very large plan for a national grid was just approved by the government for some massive capacity upgrades. I mean, that's the tried and true method: is build more, replace what's old, and it is needed, especially with the current utility model. I mean, microgrids are cool to talk about, as I was using the Puerto Rico example, but there is still a large industrial, commercial load base, public transit, hospitals, universities, manufacturing, just a base load that is still there and demands complete reliability. When we talk about kind of that reliability curve and demand curve, there's things you can do to tweak it, but you need to have a base load that's there for generation in general. And construction is kind of that key lever that we can always pull. So from a capital construction priority, when you're looking at that, then you start to have other questions. So diving into, okay, let's take a look at just building and renewing. Well, what do? Do you focus on renewable generation? Do you support EV infrastructure for demand side management, partnering with battery storage companies, working with developers? Do you focus on T-line, D-line upgrades, whether it's improving the conductors like we were talking about earlier, or the voltage levels or the rating or the type of structure, which may need additional right-of-way? Do you look at substation retrofits, or do you look at undergrounding? These are all decisions that a capital program needs to make, and typically you're only given a bucket of money, or you have to justify all the costs that you're looking at doing, which can take time. And so it's all about time to in-service, time to delivery, and time to benefit the customer, which ultimately allows you to recover in capital recovery costs. But what is someone to do? So what we're trying to look at is, from a capital construction standpoint, and this kind of is starting to brace a little bit more, veer a little bit more into where Exodigo, where I'm working at, is looking to help improve some of these, is coordination and speed. Are, regardless of, if we go back, regardless of the type of construction you're looking at doing, and like I said, we're focusing on kind of that construction vertical, coordination speed can win or lose the day. And so when we look at some of the problems or considerations that utilities can run into, landowner engagement, you're looking at doing a new right-of-way, you have this great routing, you have this great placement, but you have to engage with the landowner. You may run into an owner that is very, very anti what you're doing, which can then slow down things. And if you have alternatives, can you be ready to go on other locations, or are you stuck with that area with the challenging landowner? Going to that location of install, how have you decided? There's a number of factors that can go into play. For example, EV charging. Do you focus on petrol stations and look at retrofitting those? Do you look at where, if you're already increasing capacity to fleet locations, do you try to encourage consumers to charge near those locations because of the additional substation capacity and kilovolts that you've already increased in those areas, and looking at how those decisions are made? And that goes to routing. At the end of the day, you're increasing circuit capacity, but also trying to optimize it. The CEO of Exelon, which is a large utility in the U.S., actually made a very interesting comment that I hadn't thought of. Is right now, at least in the U.S., which I think is the same in the U.K., Hospitals are in a redundant circuit where if one circuit fails, the other one is still providing power, typically managed by two or more substations. But when you look at charging facilities, at least in the US, it's single, usually typical, like even a single fuse, or sorry, single feeder. Um, and so looking at if you're electrifying bus fleets, you're electrifying Amazon delivery warehouses, electrifying grocery stores, and you're looking at routing, you can't just think of single feeder lines anymore. You have to look at redundancy and maybe even treating them as a critical infrastructure and looking at how that impacts in the construction, and then behavior of your consumers. Looking at right of way encroachment permitting, uh, coordination again key. Cities, counties, regulatory entities, making sure you're following procedure, misconceptions of what's the actual ground, what's the actual rights, what's the actual who owns what, where are things, as you're looking at these construction projects can be a big challenge. And then right sizing, making sure you're not overbuilding and how do you get that capacity commitment from your owners. Maybe, for example, data centers. They're in the U.S. They're fairly flighty, I'll call them. They can say, "Hey, we have this huge capacity, but if you're not going to give us a cheap price, we can move easily or relocate." So you've put all this infrastructure in place, and now the load may not be what you're expecting. And how do you either right size that or get some sort of customer commitment to that new capacity? And then, like I had talked about, redundancy in terms of making sure that these new electrified assets are for the greater public good and are running reliably. And then, just as part of speeding up delivery redesigns, these are all considerations. If I was there in person, I would love to take time right now and just talk about some horror stories that you all had. But again, feel free to send those to me via email. I always love a good read. So to kind of talk about where I'm going to go with this a little bit is when I think about work management, and I'd love some feedback on the slide if this resonates with you. Again, comments are welcome. Is when a utility's planning a project, I put together this matrix when I was in my consulting days. This is how work is done, regardless of where the work comes from, regardless of how it's identified. There's a initiate, there's a planning, scheduling, completion process, and then a GIS posting. And I mean, when you engage a utility, there might be certain nuances, but at the end of the day, utilities have a core fleet of people and operators and construction crew, or I mean, contractors, obviously, who perform the work. And it all comes down to how do you get your work done? And you have these competing types of work. So you have these wonderful large capital projects, which I have highlighted here as really a goal, an altruistic goal of getting them done, getting them built, getting them per regulator standards and what you've told your regulators will be done for capital improvements. But at the same time, you have failures, you have storms that come in, you have compliance activities, and then you have customers who are still doing normal. I'm moving, I need new service, I'm upgrading, I need two more meters, or I'm building a multifamily house, I need additional service, which I mean is a normal part of utilities. So how do you not only manage your capital projects, but how do you manage your work as a whole? And that's really my not selling my own old self because I don't work there anymore, but that's what I did as a career was how do utilities manage their resources effectively? And so efficiency is key. And so what Exodigo is looking to do, as an example, again, I'm not trying to pitch you on Exodigo, but Exodigo is an underground mapping technology. We use AI to find underground assets and create a digital map. And so this is an example where AI can standardize decision-making processes, and I'll kind of go forward a little bit. Basically, uses sensor fusion to stack how data is collected, and then it uses AI to quickly and rapidly create an underground map. And I'll show you some examples in a second. But what we're trying to do, and what we're getting success actually at National Grid, which I know has business in the UK, is say you have two projects, each have a budget of $6 million. So right now, when you're looking at underground budgeting, a lot of the budget happens from past experience. And so two project managers or planners may have very different experiences on their past project. And right now, I will admit, maybe your utility or your group is great at this, but looking at historicals and figure out what the actual root cause of budget overruns can be challenging because there's a lot of anecdotes, there's a lot of context that needs to be known. And so asking the question, hey, how much of your project was delayed because of X is a tough question to answer. But what we're seeing is if we can quantify the underground portion, it can be up to 20% of a contingency for a project because it's unknown. You can't see it. Uh, you're unaware of it, and you can only have past historical gut feeling on what do I think this is going to cost from an underground risk standpoint, and then you put a contingency of this is what the budget is with a contingency around it. And so what we're saying is, can you use AI to get you a better understanding of what the underground matrix is, give complexity even for overhead structures. So if you're building a new transmission right away and there's nothing there, then you can reduce the contingency, you can reduce the budget and say, okay, and maybe now that project only costs $3 million, but you're building a new urban substation with a number of distribution feeders and underground lines, and you're in the middle of an area and where you thought maybe there wasn't a very large concentration of assets, you find out that there's now a transmission gas pipeline or a fiber line down that line. And now that cost, we can, to a certain degree, say now it's going to cost $7 million. But at the end of the day, you're still moving in your in-service date for both projects because you're able to get that budget certainty. And you can make sure that my experience in these projects is if you give someone $6 million, they're going to spend $6 million. Now you can give them $3 million, have a much better understanding of that it's going to cost $3 million, and then your variance is much lower. And so we're looking at, again, from an underground perspective, can we use AI and help those upfront decision-making processes for contingency management? Again, from an Exodigo perspective, then that leads to, okay, you can make decisions earlier, get that design certainty, you can have better schedule adherence, and then you can ultimately reduce cost. And I think not just with standing Exodigo, this is really what a lot of the startups are doing is, can we get data in your hands earlier? But the challenge for you all is what data is required to help you make those decisions faster. And so kind of going back to the categories of, do you buy smart devices? Do you upgrade conductors? Do you do capital projects? We as a company at Exodigo have made the decision to focus on benefiting capital construction because that is a standard thing that utilities understand but could do more efficiently. But there's also a lot of tools out there that are trying to help with the decision making of, okay, what's the benefit of doing this IoT versus this IoT? And those are valid questions that you guys need to ask. But I think that at the end of the day, and what I would open it up is, what's important to you all now? Are you trying to build things, trying to buy devices, trying to upgrade conductors? I'd love to kind of hear that. So feel free to, like I said, to send that in to SJP, and we can have a discussion if it makes sense later on. Again, like I said, our technology uses AI to find the underground. We scan an area, create an AI map, and then looking at, okay, how do we improve design, execution, and closeout? For example, coordination efficiency, reduce redesign. And then ultimately, if you look at it holistically, and this is why sometimes startups are put in a little widget like, hey, you can help with marking underground facilities. Well, if you look at the whole process and going back to my work management process, there's so many stakeholders. Right here, I can count, 12, 13 process steps, which typically have multiple stakeholders and groups that may not be aware of the other's job and where their cost savings may come from. So one I like to always point out for us is, when you're looking at a damage prevention in the US, there's a cost center that is fully responsible for marking utilities for other parties. But the marking of those utilities is not very accurate a lot of times. If you have accurate understanding of where your utilities are that you found during your own projects, then you can leverage that data and reduce your O&M costs to say, hey, I know exactly where my utilities are. If there's construction happening in this area, I A, know exactly where my utilities are, and B, if there's no conflict, I don't even have to send out a crew to go or a locator to go out and to paint the lines or locate those facilities, and I've saved on O&M. And if I do paint the lines, I know exactly where it is, and it reduces although the liability may be transferred, there's no need to even have the discussion or talk about the blame game of who did what when if something is hit. So it really reduces that O&M cost center. So again, uh, always think about it from a big picture as you're looking at these new types of technologies. Uh, and again, this is just an example of kind of our product looking at, hey, typical substation, no idea of the underground profile. In this specific area, National Grid was looking at building up some new battery capacity here in the lower left. We provided them. Maybe you shouldn't, because there is some stuff over there that they were not expecting. We've done some work with Vinci and GRDF in France. 50%, 57% of identified lines did not appear in the records. So again, this is, and I have a number of projects where you look at current locating techniques. With National Grid, there was a metal pipe in the center and a fiber line that were missed with traditional illicit methods. And so trying to get more data can help with more decision making earlier in the process and help speed up these projects. So again, I'm kind of sharing a little bit about why I'm passionate about underground mapping, but in general, the key message that I really want to talk about and kind of have you all take away is whether it's AI for underground or system planning, capacity management forecaster that can automatically predict load forecasts for the next 5 years. It's really trying to figure out for your utility, what are the 5, 10, 15-year possible priorities, and what can we do now with the information known, and what may we have to have systematic checkpoints to readjust. Because I think we're kind of over the, hey, let's just have a 15-year, 20-year plan, and we'll follow the demand curve with that, and always be just kind of in this nice space of we're meeting demand and maybe have some peak load days where we have to buy off the market. We're going to have to check and adjust much more frequently as an industry, and adjust and react much faster than we've ever needed to in the past. So again, hopefully you all stuck with me. I appreciate your time. Sorry I wasn't there in person, but I would seriously love to have this discussion again in person. Fly over to the UK, and always happy to answer any questions that you may have offline. So thank you again, and I hope you have a great rest of your conference.
Thank you for that really interesting presentation, Bret. I know a lot of those in the UK will appreciate this kind of technology, as much of our electrical network, I don't know much about the US network, but a lot of ours is buried underground as it is, especially on the DNO side. Like the UK Power Networks has, I think, about 90,000 underground miles of underground cables. So
yes,
understanding where that is so incredibly important. So this kind of technology is vital, I think. I did have one question, and that is, we've spoken quite a lot. Well, you spoke about quite a lot how AI is helping with budgetary certainty. But I wanted to get your thoughts on how AI contributes to sustainability and reducing environmental impact during the construction phase.
Yeah, and it's always a hard question to answer, because the gut reaction is, the gut answer, which sometimes gets eye rolls, I'll admit it, is AI can help with efficiency, and then and those of you that are in construction can attest to this, but the amount of idle crews that sit around, like, it's not like it's massive, where there's a lot of inefficiency on, going back to underground. So something's identified that wasn't expected. Now you have idle crews, idle equipment, heavy equipment, and then you have to come back out. And so there is an environmental impact on just heavy machinery. Now, obviously, if that's electrified, that starts to solve itself, which actually could be a good boon for the utility, because they now get to have more revenue, but it's slower projects. So from a sustainability standpoint, having AI help make decisions on project management and targeted work especially on the construction space, which is our side, can be greatly beneficial. Talking AI in general, I think AI in general, when viewed from a utility lens, I hear time and time again, AI is viewed as being able to speed up back office tasks and repeatable tasks, especially when you're talking non-generative AI and it's more kind of machine learning. And so anything you can do faster and more efficiently just has a tangible net benefit on just sustainability and lower greenhouse gases when you're talking about, again, real equipment, real, I mean, even travel. Like,
Yeah.
I'll admit my greenhouse get like flying. I'm in Boston right now. Like if I was able to accomplish that with some AI tool rather than having to do the process I'm doing today, would really contribute to those lowering of greenhouse gases. But I will say I'm actually working with a construction company here. That's why I'm here in Boston. And even types of material selection, a human can't design most optimally to select and optimize like getting a green profile, I'll call it. Like, hey, I want to build this building, and what's the most efficient way to do it in a sustainable manner is something that will take a human a long time to do alternatives between material A, material B, material C. And having a computer and AI be able to make those decisions very quickly and say, okay, here's the trade-offs between different materials, and doing that millions and millions of times and giving you a building profile that, hey, this is much more sustainable, can actually be done like never before. And so again, a little bit outside my wheelhouse on the building design thing, but I think just AI in general, there's a tremendous opportunity for efficiency translating to sustainability.
Yeah, and I know I have another question, which is a little bit out of your wheelhouse, but it is about AI more generally. What are some of the cybersecurity challenges associated with implementing AI on a utilities level?
Yeah, and I mean, I would say it's kind of in my wheelhouse because of my past experience. So there's a concept called NERC-CIP here in the U.S., Critical Infrastructure Protection, that protects a lot of the governing utilities here from cyber attacks and terrorism related potential. And obviously that's extremely important, and especially with AI being the downside of AI is cyber attacks are now much easier and more complex to execute. Um, but sometimes a reactive negativity to that fear is causing a sort of withdrawn and circling of the wagons mentality within utilities, where one of our big challenges in Exodigo is if I find non-owned assets, do I as a utility want to know about those assets? Do I have a risk of knowing now where the water line is? I'm a utility company that now I need to protect. And if I don't know where that is my liability and risk of having that taken or hacked decreased? And that then goes against the I need to share this data with other entities to speed up projects that can have a greater public benefit. And so there's this how do I protect my data, and how do I not know about data that I then don't have to protect if I don't know about it to meet the cybersecurity challenges? But also, how do I then share data in the greater ecosphere to be able to speed up projects? And there's this sort of dichotomy of like protectiveness and openness that we're at least facing here in the US a lot, and I think is the same in the UK.
Yeah, I think people who are watching this will definitely agree that they recognize their challenges. Thank you, Bret, for joining us. Yeah, I'm sure a lot of our audience will resonate with what you've said.
Awesome.
So,
Hey,
thank you.
no worries. Thank you so much. Take care.
All right, you too.
Bye.
Goodbye.